All right, let's dive right into this explainer. We're looking at the sonic symphony of the silent vacuum. Now, we've all been taught that space is totally 100% silent, right? Well, today, we're going to completely flip that idea on its head. Scientists are literally pulling music out of the void.
So, we've got this wild paradox on our hands. On one side, space is a near-perfect vacuum, complete, total silence. But at the exact same time, it's a cosmic symphony. It's secretly bustling with an entire hidden network of vibrations. How can both of these things be true at the same time?
Well, let's unpack that in Section 1, the silent vacuum paradox.
Okay, so it really just boils down to basic physics. Sound is essentially just a physical vibration, right? And for that vibration to get from point A to point B, it desperately needs a medium. It needs something tangible to physically bump into to pass the energy along, like the air we're breathing right now or the water in the ocean. But space is a near-perfect vacuum. There are practically zero particles out there to carry those sound waves. So, if you were just floating outside your spaceship right now and decided to shout at the top of your lungs, absolutely no one is going to hear you. The kinetic energy from your vocal cords has literally nothing to travel through.
Which brings us to a pretty massive puzzle. If sound simply cannot travel through a vacuum, how on earth do scientists actually hear space? I mean, what exactly are NASA missions recording if there's no sound out there to begin with?
Let's figure that out in Section 2, Catching Invisible Space Waves. Here's the trick. Instead of traditional sound waves, space is absolutely packed with electromagnetic waves. You can think of these as invisible signals constantly pulsing through the cosmos. We're talking radio waves, plasma waves, intense magnetic vibrations, the whole shebang. Now, our biological human ears can't pick these up, obviously. But our spacecraft? They are equipped with specialized instruments built specifically to detect them. Our probes are out there right now, acting like giant antennas, scooping up all these invisible electromagnetic signatures from planets, stars, and deep space phenomena.
So, how does that data become something we can actually hear? That brings us to Section 3. Translating data into sound. This whole translation process relies on a super cool technique called sonification. Remember, those electromagnetic signals aren't sounded first. They're just raw data, just numbers hitting a sensor. Sonification takes that data and runs it through 3 distinct steps. Step 1, scientists capture the raw radio or plasma waves. Step 2, they mathematically convert those exact frequencies, pitching them up or down so they actually fit into the range our human ears can process. And finally, Step 3, they just play it back as audio. It's literally translating the universe's invisible energy into a format we can listen to. We are mathematically mapping space into sound.
Now that we know how the sausage is made, let's move to Section 4, the cosmic playlist.
I gotta tell you, our local solar system playlist is absolutely wild. Take Jupiter, for instance. It's got this massive, unbelievably powerful magnetic field that cranks out intense radio waves. When you sonify that data, it sounds like rushing wind or crashing ocean waves. It's super powerful. Then you've got Saturn, which gives off these eerie, almost sci-fi-like whistles and sharp crackles. Honestly, it sounds exactly like the tense background audio of an old alien movie. And right here at home, Earth generates its own totally unique signature. You get these lightning-related radio bursts and the sweeping sounds of our glowing auroras. Every single planet has its own unique voice based entirely on its physics. But our local neighborhood is really just the tip of the iceberg. The most haunting sound ever recorded using this process comes from way, way beyond our solar system. Specifically, from a supermassive black hole located deep inside the Perseus galaxy cluster.
When researchers took the electromagnetic data from the extreme environment around this specific black hole and sonified it, well, it didn't sound like rushing wind or crackles. It revealed this deep, resonating, incredibly haunting hum. And what's truly mind-blowing is the sheer scale of this frequency. This hum naturally occurs at a pitch that is millions of billions of times lower than what humans can normally hear. Millions of billions. They had to mathematically scale it up an unfathomable amount just so our human ears could even detect it. It is literally a heavy cosmic baseline echoing through a massive cluster of galaxies.
Which leads us nicely into Section 5, Why Listening Matters. You know, translating these space waves into a playlist isn't just some fun novelty. It has massive scientific value. Listening to this data, instead of just staring at it visually on a silent chart, gives researchers a completely different dimension to analyze the cosmos. It lets them study complex magnetic fields and track space weather in a really intuitive way. They can essentially hear how planets are interacting with the solar wind as it rushes past. But the biggest takeaway? It allows scientists to detect and study phenomena that we literally cannot see with standard optical telescopes. By adding the sense of hearing to our toolkit, our brains can pick up on patterns, rhythms, or tiny anomalies in the data that our eyes might completely gloss over.
So we come back to this central paradigm-shifting thought. The universe might seem completely silent to our unaided human ears, but with the right tools, it's actually this vibrant, vibrating environment that is just packed with hidden activity. The universe literally has a hidden soundtrack. So the question is, are we finally ready to listen? Next time you look up at the seemingly quiet night sky, just remember, it's actually playing a magnificent, invisible symphony. We just have to tune in.